Looks like we're on. It didn't even, I don't know why it ain't linked. Oh, you must have, oh, you took it off.
Did
Okay. Well, we're live.
All right. Well, welcome to the High Voltage Live Show. I must have took it off because of my did that video.
Yeah.
So my bad, dude. I should have put it back on or told you or something. So my mistake. Welcome to the High Voltage Live podcast, and like I say, I'm your host, Willie Snyder, coming to you live from the Ohio City, Denver, Colorado. Joined by my awesome co-host, Mr. King James Stalkup, over there in Big Sky Country, Texas. And I know you guys don't love missing out on the introduction, but that's awesome. It always gives us time to collect our thoughts and say what's up. And don't forget to smash that like button, hit that subscribe, and get us to 500, man. That's what we're trying to get. So appreciate you all up there. We already have David Englehart up in the house. What's up, Mr. E? Yeah, dude, electrical code nerds in the house, man. Represent those code nerds, And yeah, dude, I noticed that there is a lot of that copper clad aluminum debate getting heated up. They're putting number 16 in and stuff. So, yeah, dude, I'm glad that you're attending that. And, dude, IEI is a really good group to jump in with. So, be interested to see what happens with that and see how that goes. And don't forget to check out King James's his learning management system over there on Learn Worlds. It's really awesome. Like I say, when you guys look at it, we ask you to compare it to any other anything out there, and we dare to show us something better. We haven't seen it yet. I don't want King James to get all like thinking that it's not going to happen. So never know. I mean, there's still some time. It's been 5 years we've been challenging people to show us something better, and you never know. It still could be out there. Still, so you're telling me there's a chance.
Oh yeah.
Yeah.
There's a chance always. Probably not going to happen, but
yeah, we'll see. I don't know. But we already got Daniel. What's up, Daniel? Starting a new company over here. Pretty awesome. He's got that cojones to jump ship and go start a new job. That's freaking awesome, Daniel. And I love the fact that you've been working independently as a journeyman pretty much your whole career. So
yep.
I didn't mess up the soundbite for Daniel. So sorry about taking that off, King James. I forgot about that. And
you're making me look like an amateur tonight.
Yeah, it was my bad. I should have told you. I did a little video for like my podcast for the Willie Jackerson experiment. And, like I say, they have like a little video clip where you do a little thing. It was like I just did it while I was, live last week, and apologize for that. I messed it up. But, yeah, dude, that's cool, man. Taking the week off. And, yeah, dude, don't have to be ditch digging this week. So, that's pretty cool, man. Like Daniel's got the week off. Dude, you would love this. So, there's a story. Daniel will love this too. So we asked the first year apprentice to go get us 3/4 inch set screw couplings, and he knows what we're only using one coupling. Like we're either using rain tight or we're using set screw, and so we're in a dry location. We're using set screw. So he goes down there to get set screw couplings, and I was like, what is he doing? And he's taking a box and he's putting all the set screws back in because all the set screws fell out. And I'm just like, take the box up there, put the set screws in while you're up there. Bring the set screw, bring the couplings first. But that's what the meme was inspired from this week. And so maybe we'll roll the meme and everyone can get in the head. Now that is a true meme from the heart. I was like, I even showed it to him the next day. I was like, dude, this is what you look like when you went to go get couplings. He's like, yeah, I know. He's like, I should have brought him up, then put the set screws in. I was like, yeah. I was like, and so it was funny because one of the journeymen, he went and took a smoke break and then came back and he still wasn't back with the couplings. Like, what is he doing? We need couplings, But it was pretty funny. It was a good joke. But Daniel knows how that is. That sometimes the first years are kind of hard to work with because like they get that mental block and they just don't realize what's important. But big shout out to my apprentice. He took the joke and he took it well, and that was really cool. That he was a good sport, and the next day he was awesome. He totally kicked butt. Ran probably about 60 foot of conduit by himself. Ran perfect offset, everything. So he's getting better. And like I say, everyone in the comments, thanks so much for the participation in electrical code discussion for awesome electricians. There's a lot of cool comments in there, and everyone's on the same page. Like, at least he didn't bring back PVC couplings. I was like, yeah, that's something, or bring back connectors and something like that. But like I say, these younger guys, we got to bring them up. We got to help them learn. And a big shout out, bro. You learned, and big shout out to IEC Rocky Mountain. That's the school I went to, and they're a really good organization. So they're bringing up good electricians, and we're all getting better every day. But you'll love this audio soundbite we have this week. Let me know if anything you want to stop it. The thing is, what's so awesome is Jeremy says he didn't get destroyed, but he got destroyed. Let's check it out.
That you are not out in the field, like you do not know field. You're not a field electrician. Like, when's the last time you've been in the field? It's been a while, but I'm getting one. Yeah, it's still. No, it's still no. Okay, no one can go. There's no very just a pitch on the job site that doesn't look there. No.
It's hard to hear.
There's not many installations that I've seen in the last 20 years that have 80% rated breakers, especially over even like 100 amps.
So the one point I was trying to make is that there's two different standards between switchboards and panel boards. And what Weedman's talking about is all panel boards, and what I was talking about is all switchboards. 90% of all switchboards are going to come with 100% rated breakers, and probably 90% of all panel boards are going to come with 80% rated breakers. So it's kind of how Weedman is. He tries to twist their words and twist what they're saying, and I'm just telling him like, hey, what we do in commercial, we don't deal with that. And he admits it right there that it's been a while since he's been in the field, and it shows. So,
well, that's funny because when I had my little debate with him, I basically told him, you need to get out in the field and see what's going on out there, because it's apparent you hadn't been out in the field. Because when we were talking about they'll take a 20 amp circuit and then go to individual rooms in number 14, I said that's common practice, and he goes, that's not what the code says. After he realized that he said nobody does that. I said, you don't know what you're talking about. I was like, well, hey, that just goes to show you're sitting in your ivory tower offices there and you don't get out and actually see real work in the field.
100% agree. And so I wanted to show you, this is the clip where you actually school him on the 900 amp debate. He always comes in here and starts asking us. He's done it every week. So this is the actual audio. Here you guys go.
All right. So your 724 amps continuous load got us to 905.
It's very light. It's hard to hear.
So why can't I use a 850 amp or why can't I use an 825 or
that better?
863?
Am I quiet?
Yeah.
Let me see.
It's not as loud as usual.
Let me see. See if I can fix some. 'Cause, yeah, I could usually. I thought I fixed it last week, and I kind of messed up. Let me see. Jump out real quick. Let me.
Well, he's gone. Let me turn this down a little bit because that's just way too big. There we go. Since he's out until he comes back in, tries to work on his audio, what we'll do here is, well, he usually likes to be here when we're doing Myth of the Week. So I don't want to move on from Myth of the Week from him. Let's see what else. He's got Tool of the Week. Well, I guess we could. Well, it's, something that's interesting here. They've been adding to a lot of this.
Hey, is that better? Is that louder?
Play the audio. I can hear you. It's the audio I was having trouble hearing. It's still. Yeah, it's choppy and you can barely hear it.
Really?
Let me undo this and see if this maybe. Does everybody else hear it okay?
It's showing on my end that it's loud, but it's not. It's weird.
I hear you okay. I just don't hear the audio.
That's weird.
Does anybody else having trouble hearing the audio?
Yeah, they were last week too. Everyone was saying they were having trouble hearing it. Let me see. That's mute. Let me see settings. It's weird because I had it all set up last week. Let me see. Oh, you know what? Let's see. Let me try something different. Let me try this. See if this is better.
I'm down to the next.
I'm not debating that they don't have
That's better.
Is that better?
That's better.
that available, but 240.4c just says that the conductor has to have an opacity that is equal or greater than the overcurrent device. If I put it on an 850, is that conductor?
It's doing it again.
That's still greater than 50%. So why couldn't I just make
it started out okay and then it went down.
Did it?
Yeah, it started out okay and then
let me see.
You're having problems with it.
That's weird. Like, let me see. Let me try this. Let me try this one and see if it's better.
825. Why can't I,
No.
It's not working now?
No.
That's weird. Because, let me see. Let me try something. Try this. Let's try. I got a mic. I'm going to try a mic. See if that works. Because it was working great last week. I figured it out. Let me see. Let me see. Let me try this. See if this works better.
About doing a minimum.
No.
Is that better?
Nope.
It's not working now. What the heck? That's weird. I don't understand. I don't understand why. Let's see. Audio. Because, yeah, I had it. It was on that. Let me see. Try to. So try this out. See if this is better.
I go look at an AC unit and it has
No.
Not?
I think you're having audio problems there, brother.
Damn. All right. Well, I guess I can't play the audio clip. I don't know. I'm gonna have to figure that out. I mean, that's weird.
Yeah, because I wasn't here last week, but weeks before it was loud and clear. It's not now.
Yeah. So let me try something.
See the
Let's
little
see.
thing at the bottom there? They
Yeah,
got
let me
a
try something. How about now?
Rest industry, we're all a bunch of freaking idiots. We don't agree with y'all.
Ah. Wow, that's weird because, yeah, let's see, mic settings. See, I it's like echo cancellation thing. It seemed to kind of work last week, but that may be what did it.
Where does it say that I go down to the next
there you
standard
go.
anything in 240.4c?
All it says is that. Wow. I don't know. Where does it say? Show me where.
Well, it was going okay.
Drop down to the next standard setting. Whatever.
Oh, it just stopped, huh?
Yeah, it was going right at the first and it stopped.
Wow. I don't know. I'm gonna have to figure this out. Like, I don't know. That's weird. I don't understand why. Let me see. Mic settings. Let me see if it does this. Let me see.
Over 800 amps. Pay attention. The capacity of the conductors is protected.
It's
Nothing.
trying. It's trying.
It works and then it just shuts off.
Yeah.
What the heck? That's weird, man. I don't know. I can't figure it out because I don't know. Yeah, I guess we'll just have to abandon that project. Like, it's weird because like when I have it set like this is with nothing on. Does it work?
Yeah, so that means you gotta go down. You can't go up.
Okay, fine. You go down. Why can't I go down to 850?
Yeah, it's scrambling. It's scrambled. It's like
Really?
yeah.
Wow. That's weird. All right. Well, anyway, I'll come back with that one later, but
All right,
we'll just move on to the myth of the week.
all right, here we go.
It's time for Myth of the Week.
All right. Well, sorry about that. I'll try to, figure that out and get my mic settings figured out. I had it working really good last week, so I don't
I'm
know.
gone 1 week and everything falls to hell. I tell
Yeah,
you.
I messed it all up, but I really appreciate all the participation I had. Myth of the week this week in electrical code discussion for awesome electricians. I had like real close to 100 comments when I came live tonight, so really appreciate you guys jumping on and checking out the myth of the week. Sorry about the audio. I just totally screwed up for King James. He gets me all set up, look like gold, and then I just crashed the golf cart. But like I said, I had a lot of fun with this myth. This comes from one of the gentlemen I work with. Was like, oh yeah, they have a NM Plenum rated NM cable now. That's why they color it blue. And so I did research, looked into it. There is no NM cable that is Plenum rated. And I would imagine that that's because of possibly the PVC jacketing and possibly the cardboard. I think they call it like polycloth, or I can't remember what they poly something. But I'm sure that there's materials in there that would not do well in a plenum space if you had like some kind of a fire or something. So I don't think that NM cable really is probably ever going to be plenum rated. And what I'm noticing now is they're getting away from a lot of those plenum ceilings anyway. So that's one of the things that I think was kind of cool about this myth is, people are like, oh man, they're going to make plenum rated NM cable. And it's like, what does it matter? If they get away, if they just stop doing plenums, then you don't have to worry about it. So I thought this was pretty interesting. And I told you about it the other night. And I thought it was a pretty good myth to run. And like I say, this product was from Sarawire, and like I say, I honestly think that I don't think it matters if it's not a plenum space anyway. So kind of a moot point, but all the way around the board, NM cable is not permitted to be installed in a plenum area. But we'll see. We might have some more myths spin off of this one, and like I say, really cool the way you put these together. And like I say, you just toss up 334.12, use is not permitted, NM cable. This one's really a slam dunk for King James. He didn't even have to really do any research or anything. He just, nope.
I said, not happening.
Yeah, so I did some research and tried to check to see if there was anything that was plenum rated, and I didn't find anything. So
yeah, matter of fact, when we were talking, I said, if you find something, I said, you send me that information because I'm not aware of that. I said, that'd be a new one on me.
well, and you would think that the Standards Council and the code making panels and everybody involved, like, would it be CMP3 that's involved in 334? I'm not sure what code making panels, maybe code making panel 6. It's either code making panel 6 or code making panel 3 that's involved in that. And I don't think they would have passed anything if there was a product out there.
Yeah, I was going to be really shocked because, I mean, we were talking, I said, as I keep up with stuff pretty good, I said, I'm not aware of anything like that. And normally if I'd have saw something like that as a code change or something like that, I would have highlighted that. And I said, yeah, this is a sort of a big change for a wiring method because we had never permitted that before. And that's why I was like, I'd have to see that because that's something I would have caught if they would have had an exception or something there, the 334.12 that permitted that. And I never remembered ever seeing anything like that.
Yeah, and I think it would be all the way across the board that they would implement something and be like, nah. There's got to be an exception or even a TIA. If like a product came in and they had already put it in the code, then I think they would have to issue a TIA and say that there has to be an exception if you have that product. And like I say, they're getting away from a lot of the plenum ceilings in the first place. So, like I say, that's I think what I wanted to kind of show the most is how there's a lot of things that it's evolving in construction, and really the code books just kind of staying in the past with a lot of these technologies, and to me, I think it's detrimental to the NEC to not try to kind of keep up with these technologies. I mean, one of the good examples is like show window receptacles. And I see this all the time. I go to like different places like Starbucks and different like coffee places and all kinds of stuff to like add a circuit. And the panel's packed and there's nothing in, there's no open spaces. And then I started looking around and there's like 6 circuits going to the show windows per code. And I'm like, why? Why do you need 6 circuits? Like, and then they have like one little exit, or they have one little open sign plugged in that's LED that draws like 1/10 of an amp, So I know that code was passed back in the day because of like neons and stuff. Well, everything's LED now. And I mean, even like I've done ones in like restaurants and bars and stuff, and they've had every single neon sign plugged into place is drawing like 6 amps. So and there are all these LED neons now. They're not actual neons. And so once they change, it's just kind of makes it rough for the code, because the code's saying, well, you have to do this, this, this. And then what happens is it goes down the line, and AHJ is like, they're never going to use, 6 circuits up there at the front of that window. Like, they're not running HIDs anymore,
Yeah.
I know that we had some service calls many, many years ago where we'd go to some of these clothing stores or stuff, and they'd have the HIDs trip in the breaker, and I think, oh man, it's overloaded, and then kind of find out it's just like bad ballast and stuff. And those HIDs didn't have like a longevity. Like, we had one where one of the HIDs went out, and one of the ladies went and took the HID lamp out and put just a regular incandescent in there, and it was pretty funny. It melted a bunch of stuff, but it was just, luckily it tripped the breaker. But I got in there and I was like, what tripped this breaker? I go look. I was like, you can't just put regular lamps in these, and so stuff like that we check out every day, and I'd really like to see the code kind of move more in a progressive manner towards the less use of energy, rather than the more regulation and stuff like that. So
Sure.
it is what it is, and so
it looks like your buddy is in the comments. What does he say?
How his entrance song.
Oh, Lordy.
Yeah.
Well, anyway, all right. Let's just move on from the myth of the week. That was such an easy one.
Yeah, it was.
Really a lot to think about that one. I was like, yeah. When you asked me about it, I was like, yeah, you can run it, but unless there's something out there I'm unaware of, which I was right again. All right.
Yeah, and like it was weird because the comment was made to me and was like, oh yeah, they're actually making a Plenum rated NM cable. That's why they color it blue. And I thought, man, maybe there's some truth to that. So that's why I posted up the blue on there. I don't know why NM is colored the way it's colored. There's yellow, there's white, there's blue, there's purple, there's all kinds of different colors. A lot of people say it's because of different kinds of things, and honestly, I don't think there really is a rhyme or reason what color they actually color the NM cable. The AHJ is gonna like look at your gauge markings on the it's a listed cable. They're gonna look at that, and they're not gonna really care what color it is as long as you're doing it right. So like I say, I thought that was a good comment though.
I always thought that'd been a pretty good idea if they did like 14 in white and 12 in yellow and 10 in blue and 8 in orange. That'd be so much easier for people to recognize it and know exactly what size it is. But they don't do it that way. So
yeah, and so I just wanted to let all the apprentices out there know not to listen to Jeremy. So what it is you have to calculate the ampacity for show windows, how much show window you have, and you have to have that. I think it's a certain amount of VA per show window footage, and then you have to calculate how many circuits you need. And I've seen ones that were like 69 feet and they had 6 circuits. So that's a calculated load, and obviously Weedman doesn't know how to calculate stuff. So pretty normal for him to come in here and make some idiotic comment, but we'll move on.
Well, when you're looking at show window loads and you're doing the calculation for them, you're going to set that up, and you're going to do it at 200 volt amps per
Sure.
every foot of show window. So
Sure.
for the apprentices out there that are wondering what
Yeah.
it is, and you can learn that all. Listen to this, Jeremy. The best electrical publications in the electrical industry and the best illustrations, and go over. We got it posted there. Go to Stalk Up Electrical Education over at Learn Worlds, and we.
Oh, really? That's only for service, huh? Mm. All right. So shows that you haven't been in the trade there. Yeah. Yeah. Okay.
That'd be correct. And when you're doing the calculations in the 2026, Jeremy, what section would that be? You need to look it up real quick, because I can tell you what it is.
True.
I can. I'll give you a hint. Just sort of go from 220 to 120. That'll help you a little bit, and go to
Sure.
0.14. That'll get you in the right direction, Jeremy. And
There you go.
and if you want to expand on that a little bit further, Jeremy, there's other things you can look at too. And if you go over and look at 120.46a, that deals with your show windows. It sort of tells you the same thing. But when you go over and you look, there'll be an informational note that will refer you right back to, guess where, Jeremy? 120.14G. And if you want to know about the track lighting portion, then you look at 120.46B. There you go, Jeremy.
Sure.
Just to give you a little helping hand, stuff I can just do off the top of my head that you wouldn't be able to do. So
Yeah. Yeah.
So let's go look at topic of the week.
All right, let's do it.
All right. Finally, I get to do a topic of the week.
I know. Like, good thing my audio broke.
I'm just like, man, it just seems like every time I get into this week, something comes up. I can't get to it because it's going to take too long. I'm like, you got to freaking be kidding me.
Nah, you're good, bro. I appreciate you putting together the show last week, dude. I know you were freaking hurting unit, and you didn't even have to, do as much as you did, but that was pretty awesome. So.
Yeah, I will tell you, I was feeling pretty bad. Man, I was coughing up, freaking brown, yellow, dry, everything you think, man. I'm telling you, it was Monday when I first got out of the house. So it was a good 5 days before I even got out of the house. And
I don't know what's wrong about what King James said, but yeah, I think he's right on everything. So,
like, try. I don't know what he's talking about.
Yeah, he's just saying you're wrong, I guess, but I don't know. I think you're right. You've cited all the same code references. He said 120.14, so I don't see what's wrong, Weed Man. But
yeah, and since he's saying that, he's saying I'm wrong as always. He likes to say that. When you go over and you look at if you're in the 2023, you're looking at Article 220. But if you're in the 2026, you're looking at Article 120. And it's interesting, Jeremy. What is the title for that article? I think the first thing it says is branch circuit. Then the next thing it says is feeder. And then the next portion of it says service load calculations. That's interesting, isn't it? Because what Jeremy was just telling me, that it had nothing to do with branch circuits. Apparently, I guess that's what he's referring to. But anyway, and I just tell everybody, go look. and see if I'm right. Okay,
Yeah.
that's the way you do these things. You know, it's like I say, Jeremy never puts anything down and tells you where to go in black and white. He gives opinions. And I'm telling you where to go and showing you what it says. I'm giving you black and white. Okay. So looking at that, let's take a look here at one of the changes that took place. This is 240.6C, and this is where you're going to deal with local restricted access for your adjustable trip circuit breakers.
Oh,
And
dude, thanks so much for that comment, man. Awesome. If you're first time jumping in here, looks like ESB. Awesome comment, man. He's really liking that illustration. SB, welcome in the house.
you know, SB,
Jason
one
joined.
of the things, you know, like you look at that adjustable trip circuit breaker, that's not a picture. I drew that. And it's hard to see it here, but when you go to the learning management site that we have there, when you take and increase that, you'll see all the markings and everything on there. I literally drew every bit of that. And then the switch gear I drew too also, and they got the newer switch gear. It has the digital readouts on it and everything. And I drew all that in too. So when you go in and you start looking at our illustration, and you're going to see a whole lot of illustrations like this. You know, we put a lot of time and effort in putting illustrations together that's something similar to what you're going to see in the field to give you a good reference point. You know, but listen to Jeremy. Jeremy will tell you the illustrations suck, that a real code instructor doesn't teach from illustrations, which is news to me because I taught for NFPA and they used them. I've been to IAI seminars, actually have taught for IAI where I've come in, done seminars and stuff, and everybody I watch does exactly what you see here. Probably not as detailed as these illustrations, but they, you know, that's what we do. And of course, if you go over and like Jeremy posted from his OneNote, they've got lesson plans there and all they do is ask questions. They don't really, that's it. He didn't show me anything that they teach from. So that gives you an idea. That's one reason I feel the union is really taking a step back all of these years is because they don't provide the good material out there for their students to learn from.
100%.
So looking at this C where we deal with our local restricted access to our adjustable trip circuit breakers, what they did in this section, they tell you here where you have a circuit breaker and it states this, where it cannot be adjusted remotely to modify the current setting. So that's your long time pickup setting. And it says, and it has restricted access to the adjustment means shall be permitted to have ampere ratings that is equal to the adjustment current setting, which is your long time pickup setting. And it says that when you have that restricted access, in order to achieve this, you have to apply one of the following methods. So the methods that you have is the first one is it's located behind a removable or sealable covers over the adjusting means. The second one is where it's located behind bolted equipment enclosure doors. And the other one is located behind locked doors where it is only accessible to who? Qualified personnel. And the last one is where you get in and it talks about where it's password protected. And those passwords are only accessible to, once again, qualified personnel. So those are the changes that they made here to deal with your local restricted access adjustable trip circuit breakers. Okay. Then the next one is where they get in and talk about them where they're remotely accessible. So when you get into remotely accessible type, you get the only things that they really changed here is some of the language. Okay. And one of the other things they did is when you'll get down to 2, it'll be D2, and this is where you get in and you deal where it's connected to a network interface. And when you get to B, they're going to talk about the cybersecurity. But when you get over and look at that, they've added a word there, risk assessment.
Okay.
Now, the reason you got to be familiar dealing with risk assessments of the cybersecurity network is because when you go in and you look at 70E, 70E is going to help tie this in. And the reason that does is because 70E talks about doing risk assessments. Okay.
Yeah.
And they tell you that that assessment has to be completed. And of course, that assessment and everything you do has to be what? Documented. Okay.
Yeah, we had a pretty good question come in from SB. What is the difference between switchgear and switchboard? Is switchgear, just a bigger breakers? And that's a good question.
Well, when you get in, you start looking at this, and this is a good question because a lot of people, I'm trying to think of how I want to phrase this.
I mean, I think MCC would be kind of like, I would believe that switchgear, switchboard, and MCC would be listed under different standards.
Well, the term gets mixed up a lot. Let me explain it. And this is the way I look at it. When you're looking at switchgear, what is it really for? It's heavy duty and it provides high types of protection. Okay. So when you're dealing with switchgear, what does it do? It basically controls, protects, and it isolates your high power electrical equipment, which is usually what medium to high voltage systems.
True.
Okay. And that's the way you look at it. And when you get to your switchboards, what does it deal with? It's to distribute power to your lower voltages. I guess that's the best way that I could explain that.
Yeah, and I would say like a MCC would be kind of almost like a little bit more of a unicorn compared to those, because you don't really know what voltages you're controlling in that MCC. Like you would have to go off like whatever, you could have some motors that are 480, you could have some motors that are 4160 coming off that same MCC. So it kind of like isolates, your different motors through that motor control center.
When you're looking at that switchgear, what does it use? It uses circuit breakers, protective relays, and CTs and PTs, things like that. And those are put in place to do what? Interrupt fault currents. That's what's very important. And usually when you're looking at switchgear, another important part of that, in my opinion, is its design, its construction is what? Arc resistant.
Right.
That is a very, very important part of this. So when I think of switchgear, I think of it as a type of system that would handle serious faults and protects the entire electrical network, basically. And when I look at a switchboard, well, what do you usually have in switchboards? You got breakers and fuses, and it has limited fault handling compared to using switchgear. And the other thing that's very important, when you get in and you start looking at the switchboards and the distribution stuff, usually it's also one other important part. It's usually only what? Front access.
True.
That's something a lot of people don't think about also. And that's another very important part when you're looking at that. So I think that helps get you in the right direction of understanding what the difference is between the two.
Yeah, I mean, that was a really good question, so I appreciate it.
Sure. And, when I look at that and somebody asks that type of question, that's mainly what I'm thinking about when I'm looking at that. And also think of it this way. And this is sort of a cool little thought process on this. When you look at switchgear, where is it usually used? It's usually where? Substations, industrial plants, and large facilities.
True.
So
Yeah, no, awesome question, SB. Keep them coming, man. Any questions you want, put them in the chat.
Yeah, so basically look at it this way. This is a good way to put it. Switchgear, what does it really require? That's heavy duty control and protection. And when I'm looking at a switchboard, that's distribution and organization.
True.
Basically, because you're knowing where everything is, but switchgear, you're going to bigger items that you're feeding.
True. Yeah, and like I say, the more questions that people pop in the chat, I love picking King James' brain. I'll call him sometimes, and he won't even answer because I asked him too many questions that week. I only have a limit of questions I can ask King James per week. So you guys get him in there now because this is the time that you can get him. And so SB gives you a big thank you. So appreciate that, SB.
Yeah. Also, when you look at ground fault protection of equipment, now you'll remember 2 weeks ago, I think I was in 215.13. I was going over this, and this is where you deal with the ground fault protection of equipment, your GFPE. And what they did, they've got two new subsections, really. You got 240.13 A and B. The A is where you're going to deal with your solidly grounded Y electrical systems, and B is the solidly grounded DC electrical systems. And if you remember last week or 2 weeks ago when we were looking at feeders, they added B, which dealt with the solidly grounded DC electrical systems. Okay.
Right.
And what we got into there was talking about the same thing that you would require if it was a Y system. If you're providing it upstream, you don't need it downstream. Okay.
True.
So what they did here, they tied all this in to tied in where you got 240.13 A and B, and then you got 230.95 and 215.13. Okay. Or it's 18. Well, I can't remember. They move stuff around so much, but the way they set this up is just to tie in the overcurrent protection device requirements here with what's required for feeders and overcurrent protection devices for services. Okay.
Okay.
As it pertains to your ground fault protection of equipment.
Right. Okay.
Now, this is I don't even know what to really say about this, but this is location in or on the premises. And this is where you come down and it talks about not located in bathrooms. And all they did is add overcurrent protection devices here. And we know that they can't be located in where? Bathrooms, showering facilities, or locker rooms. Or should I say locker rooms with showering facilities. And then they add an exception that was below this, and they say that your overcurrent protection devices shall be permitted to be installed in existing panel boards that were installed in compliance with previous editions of the code that permitted those overcurrent protection devices to be installed in bathrooms. That is an older installation, trust me. And I've never seen one. I'm sure they're out there, but I have not seen one of those installations. But
yeah, and I'm sure the AHJs have like made them like rework them in like different, like remember we talked about that if you're remodeling over 50% of the structure, then you have to bring it up to current code. And I'm sure they were like, nah, dude, this is over 50%.
Yeah, and see, that's another thing. Well, when you get into looking at this, and this goes back to looking at OSHA, and when you get into OSHA, you need to go over and look at OSHA 1910.302. That'll be in subpart S. And they go in and they break down the timelines and everything, what is considered a major portion thereof, which is 50% or more. And that happened. See, if you were had an old commercial building and they happen to have that in the bathroom, what would happen at this point is, if you look at March 15th, 1972, and this is one that you have to be very aware of as a journeyman, a contractor, master, anybody that's out on the job. If you look at March 15, 1972, anything installed before then is grandfathered in, okay? Then from March 15th, 1972 to April 16th, 1981, everything was up to whatever the code was at that time. But if you made any changes, a major portion thereof, 50% or more, then you had to bring it up to whatever the current code is at that time. Sure. That's important information for y'all to know. That's something you're not going to learn from like Jeremy's class.
Oh, okay? Yeah.
He wouldn't, because he doesn't know any of that stuff.
Yeah, he doesn't. Question for you. How close do you think you are for the state of Colorado? Because me and Daniel, we're kind of chomping at the bit. We want to get our CEUs done soon.
I'm busting as quick as I can. And I've already submitted to the state of Colorado. I hadn't got it yet for my provider license. And then once we get enough hours and everything, I'll submit that. And then it'd be on to them how fast they give me the approval.
Okay. So would you say within about a month?
No, I'm thinking it's time they give me approval and stuff, it's probably going to be 2 months at least.
Okay.
So
hang tough, Daniel. And the thing is, you can go ahead and do your CEUs if you want, but King James has the best. It was awesome. I did King James's in 2020, and I don't think you had a 2023.
I'll say when we do get it completely done and everything, that it's going to be really nice. I mean, especially if you want everything that I've been showing out here on. Yeah, no kidding. When you look at these are the illustrations you're going to see here, and I'll give you an example, and you may want to increase them to look and everything, but just take like this one here. This is where we're getting into your overcurrent protection devices, where you're dealing with your systems that are rated over 1,000 volts AC and 15,000 volts DC. We even take the time, and you'll see, like right here, we show you a grounding impedance device right down here, and right below the transformer. That's one of those new ones that are set up, the digital reading one. So we show you exactly the newest equipment and everything, and those type of devices you're going to see in the field. So
yeah, and Daniel's seen the NGRs too out of the plant, and they're pretty cool. Pretty cool to see that stuff.
Yeah, and that's one of the things, we've taken the extra time to draw all these things, and I think it makes a big difference, especially for apprentices more than anybody. But for apprentices to be able to see these different type of devices and the type of equipment they're going to see in the field.
True, 100%.
All right. Now, this one is going to be interesting, because this is where you get in and you start looking at the overcurrent protection devices, and this is going to get into the listing requirements. And one of the things we did here is to show one that's an AC and one that is a DC here. And the reason that we did this is because you're going to have two different types of dates on these. Now, if it's an overcurrent protection device for your systems that are rated over 15,000 volts AC, when I get into this, it says that they're required to be listed but the listing requirements for that overcurrent protection device is not effective until January 1st, 2029. But if I get into an overcurrent protection device that's over 15,000 volts and not over 52,000 volts, that device is not required to be listed till January 1st, 2032.
Yeah, I don't know that is the weirdest thing. Like, I'm not really sure that I don't know what the public input is. We might do some research on that, see what the reason for that public input. Dude, I work medium voltage a lot, and I don't see what the difference is on. I mean, I don't see a whole bunch of medium voltage unlisted equipment like flooding the market. You know?
Well, one of the things, and I know an idea where they're going. They're getting now to where they want to have everything have a listing and labeling on it.
True.
And all you have to do is look at the last 3 cycles. Look how many different things have been added to the code that deal with the listing and labeling.
Yeah, and one thing I want to add is like Daniel's dealt with this. Usually, when we're dealing with that medium voltage equipment out in the field, we're actually modifying it, and then that's a discretion of the, possibly the site manager, possibly the owner of the, whatever, uh, you know, property that we're working on all this stuff. If they even want to have a listing agency come in, or they just get like a third party AHJ, and then third party AHJ just certifies everything on site. So I think that's why they're kind of running into a little bit of a problem here, because we did a lot of work on medium voltage equipment, and like I say, if they would have had a listing agency come in and inspect it, like I used the right torque, I used the right size bus bars, I did everything like the same as like a factory would have done, so there was really no difference. The only difference is we didn't have a listing sticker on it.
Yeah.
So I don't know. I don't really think that that's really going to impact like the gas and oil and the industrial projects. Kind of like maybe they think, well, we changed the words, now they have to have this listed equipment. I don't think there's going to be a whole ton of listed medium voltage equipment, even in 2032, kind of like what we were saying about 210.8F. Like if they keep it in there, it doesn't matter. They can just say, oh, well, whatever. And then the AHJ can say, nah, that's not an outlet.
Yeah. All right. 245.6 is where you get into, this is a new section that is going to deal with your adjustable relays and trip units. And basically what it's going to state is where you have these settings of these relays or trip units where they can be adjusted. The document, they'll tell you here, the documentation from those settings are going to be required to be available to anyone who has been authorized to design, install, operate, or inspect the installation. And of course, all of that will be available upon request to the AHJ.
True.
Okay.
I mean, I think that's kind of important. I've seen that before. We had one where like the engineer gave us instructions that set our TCCs at 10% or something.
Mm-hmm.
And we went and set them all exactly. We had paperwork showing exactly what to set them at. And then some engineer came by, was like, what? Why do you set them at that? And then explained to us, like, that trip curve's way higher. Like, we were supposed to be set at like 80%. And so, like, that's kind of important, because that documentation, it gives anyone a chance to try to look at it and be like, no, you guys did that totally wrong. And we had all the documentation and everything. We showed them, and they were like, yeah, that's exactly wrong. Whoever told you to do that's wrong. And so that's probably a good change.
Sure it is. And the next thing, we finally got into where we look at grounding, and we'll get through Article 250, and next week we'll start off where we start getting into the grounding for services and all your high voltage stuff. So
Okay.
what they did here, this is 250.8, and this is where it talks about the permitted methods concerning your connection of grounding and bonding of equipment. And basically what it says, your equipment grounding conductors, your grounding electroconductors, your bonding jumpers, and then they added a new thing in there. It says, and grounding and bonding terminations. Okay.
Okay.
So anything that's terminating, it's telling you have to use one of the following means, and you'll see in the illustration there, we've got everything listed at the top, and it says listed pressure connectors, terminal bars, pressure connectors that are listed as grounding and bonding equipment, exothermic welding process. You could have machine screw type fasteners that gauge not less than 2 threads are secured with a nut. Thread forming machine screws that engage less not than 2 threads into the enclosure. Connections that are part of a listed assembly or other listed means. And then we also took and we put a lot of extra additional information there where you could be dealing with an equipment bonding jumper, telling you to look at those sections. We talk about the clean surfaces and just making sure that there's more to it than just one section. You need to look at all these other sections to have a full tie-in to what that permitted method change is.
Yeah, and I do want to tie in some of my myth of the weeks. King James will probably get mad at me for this. I'm just kidding. But like a lot of people are like, oh yeah, you can't install a ground lug without scraping the paint. And we proved this. I was a long time ago. It was probably 2 years ago. But we proved that it's like you don't have to scrape the paint. Like do they scrape the paint when they put a ground bar in an Eaton panel? No, it's just they do that 2 threads of contact. So that's where these kind of code loops that King James tosses in there, they're gonna cancel out a lot of these myths that we've been covering a lot. And that's kind of cool that I can go through and show how this all ties in too.
What does it say? The coward that doesn't teach. Boy, I'm going to tell you what, that just amazes me right there. I've taught in front of more classes than you could ever dream of, son. I mean, I want everybody to understand that this guy, he's something else. I was an instructor for NFPA for freaking 30 years. I've taught at some of the biggest locations for them. NFPA actually used some of our material when we were doing maintenance training and the requirements as far as based on 70B. You know why they used ours? Because they didn't have nothing. Okay. Sure. We've gone to all kinds of places for NFPA doing all kinds of classes and stuff because we had the material to do it. And I was teaching in front of all disciplines in the industry, from inspectors, engineers, contractors, maintenance personnel, electricians. I mean, it just goes on and on. And Jeremy teaches an apprenticeship. He hadn't been out there having to answer questions in front of people that actually have been studying the code for 30 years and needing very detailed information. I've been to NASA. I've been to all the different Department of Energy and Defense locations. I've been to DuPont, ExxonMobil, British Petroleum, Arco, Kimberly-Clark. I mean, I just sat here and go on and on with this. And yet we have Jeremy on here making those kind of comments. That just goes to show you there that his attitude. And see, here we go. Show proof. This is totally amazing right here. I don't even have to show proof. People that have been in the industry will tell you, and I guess I need to show proof that I taught for NFPA too, right?
I like this comment here, King James. Yes, I asked the apprentices what they know. They probably freaking know more than you, Jeremy.
Yeah, most apprentices don't know a lot. I'm just going to tell you, they don't, and that's no dig at apprentices. I mean, hell, I didn't know anything when I first. I knew a lot because I worked for my grandfather, but then when you started getting into the code and stuff, you really start learning a lot.
And the thing is too that at least the apprentices know that there's no outlet there, AC unit, their weed man.
Yeah, well, the things that I look at as I've been doing this all these years and everything, I never ever had anybody say anything negative. Matter of fact, I was called back continuously to go. I'll give you an example of one. I did a class out at Pantex. That's out in Amarillo. It's where they make.
Oh, now Weedman's apprentices are ditch diggers now. You're digging apprentices?
No, I don't dig at apprentices at all. Matter of fact, I encourage the apprentices to get out there and learn. And when I went to Pantex, after we were doing NEC class, but it was mainly for industrial. It was a custom made course that I did for them, and we went over all kinds of stuff. And they asked me if I could take their 70E document or their safety document, and they had some stuff in there. And then I took what they had for their safety manual and I combined it with the 70E, and
nice.
I went out there for 4 days, and we would teach a day and a half. I was teaching, and then the last day they had to take a test, and if they didn't pass that test, then they were off work till they did pass it.
Wow.
And
I don't think that anywhere you said apprentices don't know anything. They don't know everything. They don't know a lot of things, but I don't think that was a comment. So
no,
might want to go back and rewind that.
Let me rephrase that again for you. They don't. And that's why they're going to apprenticeship school, so they can learn. Otherwise, if they did know, Jeremy, they wouldn't go. I mean, use your head sometimes and think about some of the comments you're making.
I don't know what GE is.
I've taught
GE.
Is that
like you went to
CE, continuing education? I guess that's what it's talking about.
I don't know. GE, maybe. I don't know. Maybe he's pre-gamed for this show. And
well, let me give you an example of something here. He comes on here and he makes all these claims and everything, and we're idiots, we're morons, everybody that agrees with us an idiot and stuff. And I've been doing it for, let's see, 63. So you're probably looking at least 35 years. And I would say that's 35 years of teaching. That's not, doing electrical work and everything. And during that time, I've been writing publications. I was on the 70E committee. I was on the 70B committee, the EECA committee, electrical equipment and chemical atmospheres. I've been alternate on panels for my dad that collected everything and established setting up the task groups because a code-making panel screwed up, code-making panel 14 dealing with hazardous locations. I've done all of these things. Jeremy's not done any of this, but yet he knows the code better than all of us.
Yeah, I don't think Daddy had anything to do with it there, brother.
Well,
I mean, he had something to do with it. I mean, he started it, but I mean.
Well, think of it this way. Well, Jeremy, don't even use that. You said my dad was a freaking idiot.
Oh, yeah.
So that goes to show you right there.
So here we have 3 comments because of Daddy. But you said Daddy was an idiot too, so because he
Well,
said you're wrong and you are.
well, that wasn't Daddy on there that made you look like an idiot, Jeremy, on that live stream.
Oh, I'm bringing the audio. I got it.
So, you know, it's just like somebody just asked me a question and I gave them a full
So he's
rundown.
an idiot, but
He is an
then
idiot.
all of a sudden King James got good because of him.
You know what I find interesting? I guarantee you take people that if they were on here that knew my dad and everything, they would tell Jeremy, no, you're the freaking idiot to even make that kind of comment.
True, 100%. I agree with that.
Yeah. And this is a fact too, Jeremy. My dad gave a report as the code making panel and correlated it and everything. And then guess what? NFPA started their process reporting based on what my dad did. That's a fact. And when I get Mark Odie on here, he'll confirm all of that because he was at NFPA at the time and was liaison of a bunch of the code making panels. So, but anyway, let's look at 250-64C. I'm tired of jacking with him. And this is where you get in. And when you look at 250.64, this is where you get into your grounding electroconductor installation. And when you get over to C, this is where they talk about it being continuous. And they're going to tell you that these grounding electroconductors are required to be installed in one continuous length without any splices or joints. That's what they added to it, the splices or joints. And then it'll say by one of the means that we're about to talk about. But this is a general requirement, but they say also except as provided in where. And they're going to refer you over to 250.30. And I think it's A5, A6, and B1. But that's where you're getting into it and you're dealing with separately derived systems. Okay?
True.
So and then they also say 68C. And when you go down and you look at 68C, what does 68C deal with? Well, when you look at 68, that's where you're going to get into your grounding electroconductor and bonding jumper connection to your grounding electrodes. And when you go down there and look at that, that's where it talks about your grounding electrode conductor connections. Okay.
Yeah, and we had big arguments with Weed Man on this because he said you could have a number 8 concrete encased electrode and these all tie together with 68C and 66, where it says that it cannot be smaller than number 4.
Well, it just goes to show, one of the things, I've argued with him and them rest of the idiots over at ECD. And basically, this is the way they look at it over there. If you don't agree with them, then all of you are nothing but idiots and morons.
Yeah, and the thing is, he's trying to say that your dad says that hardwired equipment has no outlet. He never said that. He never said that at all. He said the individual branch circuit connects to he did a whole thing on what is an outlet. And it's just ridiculous that he comes on here and says that.
Yeah, and you go looking there, all them people are going. They said finally somebody explained it where we.
Oh wow! Now all of a sudden you didn't say you could have a number 8 concrete encased electrode. Oh wow, that's crazy. All right. Wow. All right. Never said that, huh?
Have a number 8. Say, y'all did too.
Yeah.
Oh my God. Oh my!
Yeah. 100%, dude.
Anybody that is watching this, I want y'all to hear this. My dad come on and he was explaining that, and Lloyd Mills, he I don't know if he's an inspector or whatever. I think he is, but
he's just a contractor in Pennsylvania.
Oh, he's a contractor, okay. And,
yeah.
And Dad, so let me ask you a question. He said, so you're telling me that I can come into your jurisdiction and I could put a number 8 there? He goes, well, no, I didn't say that. I was like, you got to freaking be kidding me. You're sitting here arguing that you can use a number 8, but you're telling the guy that's telling you you can't, and he asks if he can do it in your area, then you tell him he can't.
So
What
there
do
was
you
a
want?
reason that Lloyd Mills was significant in that argument because he's an admin at ECD.
Oh, there you go.
Yeah, so that's why.
Okay, so they got in and they looked at continuous, your permitted methods. Of course, you can do splicing of your grounding or wire type, should I say, grounding electroconductors. And of course, that's permitted to be done by an irreversible compression type connector. Then they added 3 here, basically. You still have your sections of bus bar that are connected together to form your grounding electroconductors. You still have that, but number 2, what they added is where splices are made at accessible locations. Okay. Then you can have a splice of your wire type of grounding electroconductors, but it has to be done by a method where you have listed grounding and bonding of that equipment.
Dude, I think we have our best comment ever on this show. The grounding electroconductor to the ECD can be a number 8.
Unbelievable.
Oh, man. Yeah, dude, to the ECD, dude. You can do number 8 all day, brother. All day, man. To the ECD, man. Like, do it.
That's what
Man, it's so funny.
All right. Then number 4, they say you can have bolted, rivet, or welded connections. Of course, that's to your structural metal frames. Or you can have where you have threaded, it can be welded, soldered, or they like to have a term they refer to called brazed. Or you can have a bolted flange connection. Of course, that's to your metal water pipe. Okay.
Right.
So they allow you to do those type of connections too. And what we also did here is to tie this in with table 250.102C based
Nice.
on these sizes. So if I'm looking at this is really good. All of this is based where I'm going to where? Building steel or a cold water pipe. And y'all have heard me say this before, is when you're going to the cold water pipe or building steel, you need to use the table for sizing these conductors. But when I'm going to a concrete encased electrode, I'm going to a ground rod, I'm going to a ground ring, they have specific sizes to go to those. Okay.
Yeah, and this is where Weedman doesn't get it because he's trying to say that grounding electroconductor to the concrete case electrode can be a number 8. Dude, they're not going to do that, dude. That is so stupid. Like, they're not going to try to encase copper in the concrete and be like, oh, okay, we're going to bend up a rebar, then go like 3 foot of number 8 to the panel. Like, that, he's not been in the field, so it really shows. And I'll show next week what was said. And like I say, you might not have been able to hear it this week, but you'll hear it next week.
Yeah, and when you look at that and you go over and you look at 250.66C, this what gets me is because it'll talk about the grounding electroconductor or bonding jumper that's connected to a ground ring. And this is why I have an argument with this, because it says as described in 250.52A4. And when you go pick up 250.52A4, it says it has to be what? Number 2.
Yeah.
Number 2. And that's why I'm like, it tells you here if the grounding electroconductor or bonding jumper connected to a ground ring as described in 250.52A4. That's a number 2. And when you read that section, what does that section state? It'll talk about the ground ring that's encircling the building or structure that, of course, is in direct contact with earth. And it says it consists of at least 20 foot of bare conductor, not smaller than what? Number 2.
Number 2. Yep.
Okay. And then it says, and does not extend onto other types of electrodes that require a larger size of conductor. The grounding electrode conductor shall not be required to be larger than the conductor used for what? The ground ring. There's your section,
Wow.
Jeremy.
What
I
is
just
that
read it.
based on, Weed Man? How can it be smaller? How can the ring be smaller? What is that based on? Where do you get that? Does that come off the code?
Hold on. I want to educate for all the people.
Wow. Oh, wow. You could have a number 8 ground ring there, King James. Wow, I didn't even know this, dude. Weed Man. Wow, you're freaking educating people here. Oh, dude. All right.
What section did it tell you could use at number 8?
I guess you could have a number 8 ground ring based on a 100 amp service. You have a number 8 ground ring, 100 amp service, and then you can just connect the number 2 to it to the electrode.
Well, let me ask a question, and I think this would be.
Oh, really? The ring isn't smaller. Oh, okay. So the ring has to be number 2. Oh, okay. All right.
Well, my question is this.
So you're just running like a little 3-foot piece of number 8 from the ground ring to the service and calling yourself a badass. All right. Oh, that's cool. All right.
Let me ask this. Why would you need a number 2 ground ring, but I can go smaller with a number 8 tying into a bigger grounding electrode? And if that is the case,
dude, we showed every single time you said something stupid, Weed Man.
Hold on. I've just got a question for this, because if you look at the connection, it says connections to ground rings. Okay, that's specifically what it says. Okay, so and that's the heading to 250.66C. So this isn't the ground ring. This is the connection to the ground ring. And it says, if the grounding electroconductor or bonding jumper connected to a ground ring as described by 250.52A4 does not extend onto other types of electrodes that require a larger size of conductor, the grounding electrode should not be required to be larger than the conductor used for the ground ring. Okay, so how can I take, and if I was going to another type of electrode, how come I would have to go to that other electrode with a size conductor that is required for that larger electrode? I don't understand that.
Yeah. Yeah, he's really bad at explaining himself, and you'd be surprised that he's actually a apprentice teacher, because like you guys, the apprentices out there, they need to understand, and we have to be better as leaders to like explain it to you guys to help you understand. And I think Weed Man's is, I don't know, he's stuck in some kind of weird thing where he thinks, okay, so you could have this ground ring that's number 2. And then you have this like little short piece of number 8 that goes to your service. Well, as long as it's 100 amp or whatever.
I got another question. If I have a number 2 in the ground, Jeremy, why would I be allowed to go with a smaller grounding electroconductor to it, but I require a larger one in the ground?
True.
Why would you be allowed to do that?
Yeah.
Explain the fundamental principles behind that.
Yeah, and I mean, I don't get it. I could see, like, if you have like, usually what we do like out in the field, because Weed Man's not on the field, so he doesn't know. Like, we'll take, like, if our cold water is like a number 4, we'll take a number 4, we'll hit the cold water, then we'll just take number 4 through the ground rod. Then we'll just take number 4 through our, whatever we have there, and then we'll hit the service. And the whole thing is, we don't have to. We could take number 4 to the ground rod, and then we could go number 6 to the service. But what's the point? That's so stupid. Well, it makes no sense.
Let me ask this. Let's say that I went and I hit building steel first. Okay. And let's just say,
Oh, it's the size of the service. Because every commercial job out there that Jeremy's worked on has a 100 amp service. That's why. Oh, all right. I've
well, hold
seen
on.
that like one time, like maybe one time to like an outbuilding, and we still did it with the right way. We didn't like cut corners. So
Well,
I don't
this
know.
is a
I
good
don't get it.
question for him. And let's see him answer this. Let's go with the size service, and you take a number 8 and you take it to building steel. And then I go from building steel to bond into my ground room. What size would I need then?
True. Number 2 is what I'm saying.
Yeah, because
Hmm.
if you're looking at that, now you may have a little bit of a problem going to that. Or let's even take it a step further. Let's just say I go number 8 to the building steel, and then I go to the concrete encased electrode. What size would I need then? So, or hell,
Number 4.
let's do it this way. Let's say the building steel is tied in to my concrete encased electrode. Or what size conductor would I take over there then, Jeremy?
Whatever size 250-66 says.
So if the reason I ask this, if I go to if
No questions being changed, dude. You're just an idiot. And you don't know what you're talking
no, I'm
about.
not changing questions. I'm trying to assimilate here your thought process, and basically I'm showing everybody what a freaking idiot you are. But if I have a concrete encased electrode, and then I tie it into the building steel is not an electrode, Jeremy. So it's basically getting bonded in, but yet I'm using the concrete encased electrode. So if I go over there to that building steel and I bond into it, which is going to tie it into the concrete encased electrode, what size do you need?
Number 4. 100%.
See, that is my whole point behind this.
It doesn't matter what size service we, man.
Matter of fact, show me where it matters on the size service. Give me that section.
Yeah. The concrete encased electrodes tied into the building steel. You're combining electrodes. Tell me where the size service matters.
Because
where does it matter?
The only way he can get to the size service is he has to look at table 250-66. Okay. Yeah. So if he had a number 8, let's just see what 250.66 says. It says the size of the grounding electrode conductor and bonding jumpers for connection of grounding electrodes shall not be smaller than given in table 250-66, except as permitted in where? 250-66 A through C, which deals with your rod, pipe, and plate electrodes, concrete encased electrodes, and ground rings. Well, that's interesting because I've made the statement on here so many times where you're going to building steel and a cold water pipe, you use table 250-66. But whenever I'm going to go to a rod, pipe, plate electrode, concrete encased electrodes, and a ground ring, you have to use the sizes that are listed down below. And the thing that gets me, this talks about connections to it.
Yeah, 100%. And they can't explain that because what it does is it screws up their narrative that you have to do it their way or else you're an idiot because you don't do it the ECD way. You know?
Yeah.
And
that's what I'm saying.
He's saying, oh, permitted. Oh, yeah, permitted. Yeah, okay. All right.
Well, another thing that gets interesting, and I like to just sort of pull these little things out that makes them think about these things, is when you get in and you start looking at these different sizes. Okay. They have certain requirements in there, just like we're looking at 250.64C, where it talks about continuous when you're dealing with the type of electrodes and where they're going to and everything.
Yeah,
Okay.
and we've ran this before as like a myth. I might actually have to do this again because what is crazy that you taught me this, King James. It's electrically continuous. It's not physically continuous.
Mm-hmm.
And a lot of people say, "Oh no, that wire has to be unbroken all the way through there," and you're like, "No, like how are you going to do that?"
Mm-hmm.
You know, and you're like, "No, it just has to be electrically continuous."
Yeah.
And I like that. I like that. Like learning that. That's why we do the myths.
That's exactly why we do it.
Yeah.
But he still hasn't answered the question that I asked. And I want everybody to understand there's a reason he doesn't want to answer it, because he says, I'm changing the question. I'm not changing the question. I'm just changing the different type of installation to make him think about what he's saying is not correct.
Here's the best one of all night. I'm going to start this comment. The grounding electroconductor to the ECD can be a number 8. That's so hilarious.
Yeah.
Oh, you got permanent comment here, there, Jeremy. Like, dude, that was that's the best one. Like, that's so hilarious.
Let me ask this, okay? Because I want him to think about something else, and this is one that he's probably not going to answer because he knows it's going to kill what he has to say. But
Yeah.
Jeremy, I'm going to tell you where to go so it'll help you out. I want you to go look at 250.64F, and we're going to talk about installation of electrodes. And what it says here, grounding electrode conductors and bonding jumpers interconnecting grounding electrodes shall be installed in accordance with one of the following. The grounding electrode conductor shall be sized for the largest grounding electrode conductor required among all electrodes connected to it.
True.
Okay.
100%.
So if you go off your service, you're basically going to tell me that I can put a bar there, termination bar, and come up with number 4, number 2, number 6, but I can feed all that with a number 8 when it's telling you not to here where you're doing interconnection of them.
Yeah. 100%. Yeah.
I'm just showing people here things that you would look at. And I've said this over and over so many times. You have to take the code as a whole. You cannot just take one section and just consider that applies to everything. That is one of the big problems with the guys over at ECD. They don't know how to use the code as a whole in order to make these interpretations. But
yeah, and we need to keep America strong. So thanks for popping in. Appreciate you. LR. I'll call it LR or Leon or Richter. But that's awesome.
Let me finish this. So when I look at that, it says grounding electrode conductors and bonding jumpers. Interconnecting grounding electrodes shall be installed in accordance with the following. But this is the sentence I want. The grounding electrode conductor shall be sized for the largest grounding electrode conductor required among all the electrodes connected to it. That doesn't say anything about a service, Jeremy. It doesn't refer me to 250.66 or anything. So how 100%. can I take and size that conductor right there as a number 8 based on service size when it's telling me that it's based on the largest grounding electrode conductor?
Yeah, I mean, it doesn't matter, Jeremy. Like, you're trying to, like, say apples and oranges are the same freaking thing. It's not. It tells you right there in the code, dude. Like,
no. The last sentence there says the grounding electrode conductor. It's not saying grounding electrode, Jeremy. Once again, you don't listen. shall be size for the largest grounding electrode conductor required among all the electrodes connected to it.
Yeah.
So it didn't say anything about that. So I'm coming up and I'm making my connection with all these different conductors coming up there. And now I'm asking you here, how can I put a number 8 on that if I'm interconnecting all these electrodes when it doesn't tell me I can do that with a number 8?
Yeah. 100%.
It's very simple. And this is why I like people to watch and pay attention to what's being said on here. You don't have to take my word for anything. I'm giving y'all all the sections. Go read them and see if it doesn't state that. Now, if I can't do it there, why the hell am I all of a sudden allowed to do it for something else?
Yeah, 100%. I 100% agree. I mean, it's out of control. I mean, when these guys do this, dude, the grounding electrode for the ECD can be a number 8. Oh, man.
See, listen, okay, there you go. Then he says, yep, the grounding electrode conductor. No, you wouldn't have made that statement up above. You just proved you don't know what you're talking about. This honestly is embarrassing.
It is.
It is a number 4 concrete encased electrode grounding electrode conductor. Jeremy, oh God. Everybody, I don't even want to argue with him anymore. I read y'all the sections. Go read them for yourself and see what you think.
Yeah, enough's enough. Yeah. I mean, keep moving on. I don't know. I think it's funny because I saw that point, and I think you guys are right. You and your dad are right when it comes to how you presented that. That was a really awesome episode. You guys go back and check out the episode where we had King James Sr. on. And, dude, me and James are just sitting there awestruck at what he was telling us about the multipliers, how they came up with the sizing and everything like that. It was an awesome episode. I learned so much that day.
What was awesome about that is you actually had somebody that was there.
Yeah.
That knew why they did what they did. And the guys that are arguing against him didn't know any of this. And he's telling them all this stuff. And just like Jeremy, they said, you got proof of that? Yeah. I was simply amazed. A guy showing you. And then what was so funny about it, then they tried to prove him wrong, did some calculation, posted on her saying he's a freaking idiot. And I said, no, you didn't calculate it right. I said, here's how you do it. And then guess what? They didn't make any more comments.
Yeah, and the thing that was so cool is your freaking Pops was dude, he's so awesome. Like, he's like the coolest dude. Like, anytime I'm talking to him, he's like, you know what, Snyder? You make a good point. Back in 1966, we didn't think about that. Here you guys got all these years on me, and it's just, he's so cool. Like, the way he presents everything is so awesome. Like the way he talks to me is just so awarding. Like, he's just so like, man, you guys have a good podcast. You guys have a good time. I listen to him all the time. I'm sitting in the tub, and he never says like, oh man, you guys are wrong on this. You guys are wrong on this. He's like, you know what? He's like, I talked to my son, and we agree on this and we agree on that, and da da da. And it's like never anything negative. It blew me away. Like, I love that. Like, talking to your dad, and he's sitting there. You know what? You're right there, Snyder, on this over here. When you were saying this, you're right. And I'm like, dude, that's awesome, because that's what I want to do. I want to be right. I don't want to be wrong, And all these ECD boys, they're like, nah, you're wrong. Because why? Because it screws up their whole narrative. They can't say that. It just meant a lot. It just meant a lot. The way he talks to people is so amazing. Like, he's just like, oh yeah, you're right. Oh, you're right on that. Yeah.
It just goes to show you this guy, Oh, and if you'd have been here earlier, you would have heard about that. I'm not going to expand on it anymore to you. But once
Sure.
again, I did a death match free, giving money, all that. And he doesn't provide anything to the industry. He just comes on here and calls everybody names. And the reason he does, because he got his little rear end tore up. All right, let's move on.
100%. Let's go.
All right, this is where you're going to get in. This is where you get into your equipment grounding and your equipment grounding conductors. And they just made some changes here for further clarification where you're dealing with your metal and non-metallic enclosures. And the metal enclosures, they just told you that they gave 2 rules here you had to comply with. And they tell you if you have metal enclosures, they're required to be used to connect bonding jumpers or your equipment bonding jumpers or both. And the reason you do that, you connect them together to become part of what? The effective ground fault current path.
True.
And then it says, if you installed any type of metal covers, extension rings, plaster rings, any of your metal fittings, that they're required to be attached to the metal enclosure. So that also takes and ensures your effective ground fault current path, or they have to be connected with bonding jumpers or equipment grounding conductors or both. And then if you're dealing with anything over 250 volts to ground, they got an informational note there and they tell you to go see 250.97.
Yeah,
Okay.
so I have a really good story about that one, James. We were doing like a pool install, or it was like a pool contractor. And they called us out there and they said, "Yeah, we got a bad GFCI." And I was like, "All right." And so first thing I did was I isolated the circuit. I found out, okay, this is the GFCI that's tripping. I went and disconnected it. GFCI held. I was like, all right, let's reconnect it and we'll see if it works. Well, what happened was the pool contractor was putting these switches in like metal boxes and stuff, and they were putting them in the covers. And I was like, I don't care. Yeah, like you guys do your, he's like, hey man, are you mad at me because I'm putting these, switches in these metal covers? Like, no, dude, I don't care. I was like, you guys do your thing. I was like, I'm just trying to see why the GFCI tripped, So what happened? It was really funny. The freaking switch would like roll over, and it would the energized conductor would touch on the frame of the cover, and so the reason I found this out was because I was like, nothing's wrong with that breaker. It's working great. And this dude got lit up because there was no jumper between the cover and the box.
Yeah.
And so when the cover was attached to the box, it tripped the breaker. But when it wasn't, it lit up pool guy. And I swear to God, I saw the eyes on his face, like he'd look at me like, why did you turn that breaker on? And it's like, dude, you're the one that told me that it's a bad breaker. It's not a bad breaker. Breaker's holding. And so what was happening was that they had this like rocker switch in there, and every time it was like a key thing or something to turn the pool cover on, put the pool cover. It was like these rich people's house. And it was like pool cover would go off, pool cover would go on. And every time they turned it a certain direction, one of the hot terminals would touch metal. And so every time that turned, it would just touch metal and it would arc, and then it would trip the GFCI, which was good. That's good. But then you take the cover off, there's no ground reference.
Yeah.
So it was the same thing while we're arguing with 210.8F. If you don't have a ground reference, who cares if it's on GFCI?
That's right. All right. The last one here is metal wiring methods that are installed where you have non-metallic boxes and closures. And it just says where you have metal wiring methods installed with non-metallic boxes or enclosures, you're required to comply with one of the two. And this is where it says, if you have listed non-metallic boxes and enclosures with an integral bonding means to interconnect all your different wiring method connections or fittings and provide bonding for any metal and covers installed, shall not be required to have any type of additional bonding means or equipment bonding jumpers installed. But then you turn around and they tell you where you have wiring, your metal wiring methods, and they're used when non-metallic boxes or enclosures, then they are required to have equipment bonding means and equipment bonding jumpers installed for each metal wiring method connection or fitting. And that's to help ensure that you have the effective ground fault current path. Okay.
True. You know, like that's the whole thing. Like, yeah, we'll show the whole thing there, Weed Man. You know, it's not gonna get sent to you. You didn't win, so whatever.
Oh, matter of fact, just to handle that little portion, I'm actually going to take and have the person on. And when we have him on, we're going to have him come right on and show you the money.
Dude, that's awesome, man. That's awesome.
So when I do that, you know, more knowing Jeremy, he'll say that it's fake, even though the person's going to be on here.
Yeah. I mean, that's cool. That's so awesome. Congratulations, winner. You know, we can't wait. I mean, how is there no winner? Like, it's so stupid.
Well, you know? There is. And we will be announcing that here pretty soon with them on here. And that'll be another one, you know, that the Stalk Ups did something that nobody else would do. And we gave a prize for it. We actually put the time in to create the contest. You know, it just didn't get up there by itself. Somebody actually had to go through and do all that and track it and keep everything up to date. But no other provider does that for you. So,
sure.
You know, and I'll guarantee you the Jeremy's Union, they don't do any of that kind of stuff. All they do is come on and grab about everybody else that actually does something for the industry.
Yeah, so he actually communicated with the winner and said, hey, you're coming on our show live, and there's people that haven't communicated back, so we're just waiting. You know, we're waiting for whoever to communicate back. They'll come on live. And
you know what there was a tie. And, yeah. I'm waiting on one of them and to reply back. If he doesn't reply back here by this weekend, then he's out.
Yeah. So, I mean, it is what it is. I mean, you know, the thing that's funny is like NFPA, like they just sent me like a copyright request for like my photos, and what am I supposed to say? Like, oh man, you know, that's a Weed Man photo. No, it's not. You don't have copyright over photos. So
what did NFPA do? NFPA did that. I don't know what he's talking about.
Something about a contest where, like it was some like a contest where they gave out like $5,000 and then he won it or something like that. I don't know.
I never heard of that.
Yeah, it was the one he showed the picture where like he said all my brothers won it, but then he didn't post no pictures of his brothers or anything. It was just a picture of him.
Oh, well, that sounds like Jeremy, yeah.
Yeah, it's just that's the way he is. He's selfish like that. So I mean, it is what it is, you know. And he's saying like they gave out like $5,000 because he's such a genius at the code or whatever it was. I don't know.
For them, I'm glad they did.
Yeah,
I didn't know NFPA did that. NFPA, I could actually see them doing that. They, you know, I used to when we go to the shows and stuff. They also had a thing where you could come up and they had a little belt they put on you. Whoever answered the most code questions correctly in a row, and you got like a code beast of the show. And they had,
dude, you at least won that twice, at least.
No, I didn't participate. They wouldn't.
All right,
because I was an instructor for them.
All right.
But how would I even know that? I got proof, you know?
Yeah.
I mean, I just tell these things and Jeremy's like, you got proof? I mean, what a loser. All right.
Yeah,
ready to go tool of the week?
Let's do it.
All right.
for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
Oh, dude, you guys are going to love this one this week. This is one of my favorites. And this is a new toner that just came out. I just saw it. And this is the ideal model. Man, toners are just easy, simple things, but you have to look at like the size of the speaker, and you have to look at like how the different models, like they can do Cat 5, they could do Cat 6, they could do, I think I can't remember what the coax one is, but they do coax. I think it's like CJ6 or whatever it is. I don't remember, but you could trace any cable. You could just hook this thing up. You could trace it. You could take coax. You don't even have to plug it into this thing, and you could just take the clamps and you could just put it on the cable. You could put it on the ground of the cable. You could put it on the center cord of the cable, and you could trace that baby anywhere you want. Like, I really love this tool. It worked really great. We actually found a problem at DIA where I work, and what happened was we have 120 volts coming out of the breaker, going into a conduit, and then it's not getting received at the other end. I've never seen this in the history of my career. I was like, what is going on here? And then we went and looked, and it was crazy. I mean, the journeyman that's working with me, he actually took his power tester and just put it inside the conduit. Like, the conduit just basically fell apart because it was so corroded and everything, and it was just crazy. And the toner was ringing it out, and it was like, yep, that circuit goes to here. And so we're like, all right, we made the decision. We're like, we're not going to use that raceway, because usually what we try to do is we try to pull through that raceway if it goes there. But we're like, from here going out, it's completely destroyed. The conductor's destroyed. We saw the breaker was destroyed. The bus bar on the neutral was destroyed. And it was all because moisture was in, basically looked like a straw coming through that conductor into the panel. It was the most incredible thing I've ever seen in my career, and I've never seen anything like it. It destroyed the breaker, it destroyed the neutral, and it destroyed the wire. And what happened was they're like, okay, that quit working, we'll just abandon it. And then they took another circuit and started doing their thing. So this thing, I would have never known if it wasn't for this kind of technology with a tracer where you could put it on the wire. You could see exactly where the signal got lost. One time I was actually going through the ceiling, and what happened was they said, oh yeah, everything's all done with this fire alarm system. And, I don't know what happened, but it doesn't connect from this strobe to this strobe. And I was like, all right. So I traced that strobe. It's all connected all the way back to the panel. I traced to that strobe. It goes into this room, and it leads me in a circle. And I'm like, circle? Why does it lead me in a circle? Come to find out, it was the roll of cable sitting on the ceiling, drywalled in. Couldn't even get to it. So we ended up having to cut it, set a J-box, rerun new, because we couldn't even get the roll of cable out of there. It was just drywalled on top of the ceiling. And we couldn't cut a big enough hole to go in there and get the roll of cable. So we had to just abandon the roll of cable and just pull the cable out there, set a box, run new cable, and tie the circuit in. So it made a lot of time wasting. You didn't have to waste a lot of time with this kind of technology. So this is the one I recommend right now. I have a Fluke that works really good. I just don't like the speaker. The speaker's not loud enough. A lot of times we're on industrial projects, and you have to have a really loud speaker on those things to kind of hear what's going on. This one, the speaker's loud, and you could there's a dial on it, and you can tune it loud or quiet, whatever you want. And you can tune this one really loud so you can hear it like when you're on those industrial projects. So really like this model. This is the one I own right now. I like it, and I would recommend anyone get this one. New tone generator by Ideal. Just came out, I think, not too long ago. So really like that one.
Okay,
really
cool.
works good. Yep.
All righty. That takes and gets us to to question of the week. All right, let's see what we got here.
For years, man tried to create artificial intelligence. On this segment, we find out, is AI smarter than King James?
So I really apologize about getting you this late. I thought that the one I did last week was, I didn't think we already did it, but this one I think you'll like. This one's pretty good. It's a good one.
All right, let's see what it says here.
I might not get you because this is kind of a, well, you'll probably tell me which code section it is, everything, but might not get you.
This is going to deal with your interconnected electrical power production systems in 705.
Oof, already off to a hot start.
And if I'm
AI, do not listen. Delete. It's 702. 702 AI, delete. No, I'm just kidding.
I think it's 3%, if I'm not mistaken. It's like 705 43A or some shit like that. That's in the 40s. All right, let's go to Chat GPT. I just put.
I'm trying to fool ChatGPT, dude. Last week I went and I put it up there. Boom! It nailed it. It said King James got this one right. I was like, dang. I was like, oh, AI is on to us. AI is on to us. They're listening right now, so I got to be really careful. I got to be really careful when I do these because
Let me move.
I could be giving ChatGPT the answer right now.
What the hell? I don't know what that is. There we go. Okay. That ain't increasing. There we go. Okay. Let's see. Chat GPT, what do you think? 3%. It's what it says. It didn't give me a section though. Okay, let me go over here. Let me open it NFPA link real quick.
All right.
Let's see what it says. Okay, come on, baby, load up for me.
It looks like it has tons of power in there, like on that screen.
Okay, there we go.
Like there's all this power. It's like, yes.
What is it?
I will
Did it click off? Let me share screen. It clicked off.
Yeah, the screen's not sharing. There's probably something I did wrong. Like I probably screwed up the whole podcast. Like you had it all set up, then I just went in there and like, no, turn that off, turn that on. I didn't even realize I just jacked up the whole podcast in like 10 seconds. Like I just like, oh no, we don't need that. No, do this. You're like, dude, mother, I had this all set up.
Yeah, I have to. Yeah, there's something. Looks like you clicked something there that caused it to go off. Okay, I'll fix it. Just give me a minute.
Yeah, and nobody has to ask ChatGPT for an answer. What we're doing is we're trying to see how King James answers versus ChatGPT. So they could be right, they could be wrong. Like I'm honestly surprised. The answers that we get. It's really cool.
Okay, now let's redo it again.
There we go. It could get it wrong a second time.
Okay, it said 3%, and it's in 705, and I just looked it up. It was 705.45A, which is 3%. Okay,
man, this is awesome. Like we are getting minds and the machines together, and we are we're dominating.
Yeah, that is the correct answer. ChatGPT.
Yeah, I own a code book. It's called Link. You could go, for anybody out there, if you don't own a code book, go look up on NFPA Link, and you can look up anything you want. Just type in free access, and you could look up anything you want. So don't listen to Weed Man, because obviously his apprentices don't have a code book.
Well, he's such a great instructor, you know. 45A, that states. There we go.
Oh, wow. Oh, we got a big challenge here. So 100 electricians. All right. So first, Weed Man, we're going to need to find what electrician is. 100 electricians. How do we know what electrician is? That's not defined. That's not a defined term.
What is he asking here?
He says, come on, James, 100 electricians. We teach all the same subjects. Let the 100 say the best. 10,000. I'll be more than happy to bet that. What about you, bitch boy? And the thing that's funny is, first you have to define electrician, Weed Man. Definitions are the gateway to the electrical. So where's the definition of electrician? Like you have to define it first. That's what I'd say.
At first, I was scared to come on his live stream. I made him look like an idiot. And now, basically, when they start doing this and start saying this, they're losing. That's just the way it is. And
100%.
I wouldn't even waste my time with him anyway because he wouldn't.
And he agrees. Yep, he agrees. All right, cool. I'm glad you agree with that. So, right on. All right, what are we gonna do? Willie Quiz?
Yeah, Willie Quiz. Here we go.
Dude, that's so funny. Every time I see that video, it's like, big shout out to Adam, dude. He's such a cool dude. Man, love Adam. Dude, Adam's so cool. So question number 1. The 2026 NEC lists around 160 to 170. We all know with shipping, it's about $195. For a soft cover copy, what is the closest equivalent cost of a 2017 NEC when adjusted for inflation for the 2026 dollars? Is it A, 177, B, 200, C, 230, D, 260, or E, 300? Good luck, everyone. Probably messed up that sound too.
It was out.
Not that loud either. It needs it turned up somehow.
All right. I'm not 100% sure here, but I'll say a 177. I'm not 100% sure on this.
Ooh,
I don't think it'd be that much.
Dude,
more.
Daniel's trying to come over the top on you. 230. Oh, man, Daniel, that's a good answer. Oh, dude, Daniel. Dude, I think Daniel's going to get you tonight. I think Daniel's going to get you.
Hey, right.
All right, we have 230 as one of the answers. We have 177. Oh, dude, I forgot to put drum rolling. All right. Oh. King James gets the win. That is 177 is the answer. So we
I
have
didn't
to
think
do
it'd be that much higher. I was like, that's pushing at 177. I was actually thinking something like $130. I was thinking, or 120.
Yeah,
So,
it's getting ridiculous, kind of. All right, the 2020 NEC has a list price around $169 compared to the 2026 NEC. What is the most accurate statement when accounting inflation? A, the NEC has become dramatically more expensive. B, the NEC has stayed roughly the same in real cost. C, the NEC is significantly cheaper in real dollars. D, the NEC price has doubled. Or E, no one is going to be buying the NEC, but it's been bought and paid for by the
I'm
cheap.
guessing E. I'm guessing E just because it's funny. Okay, that's not going to be E, but that's a good one. Okay, here we go.
Oh man. That's funny.
Well, you know, being in the publishing business, I can tell you, usually when cost is going up, it's usually because of the cost of paper.
True.
And of course, it always, you can pretty much double the amount, even a little bit more than that when you're putting it in color. So those are two main reasons. But when I look at this and I start looking at that,
Ooh, Daniel's going 2 answers. Oh, dude, awesome! Daniel got 2 answers. It has become dramatically more expensive. Yeah, and dude, that was just a joke answer that I put in so King James could have a good laugh.
well,
But
I'm going B and E. I think it's roughly the same cost based on inflation due to paper cost. Because you can't get it out there way too high, nobody buy it.
All right. Daniel is going A and E. King James is going B and E. King James gets the right answer on that one. The answer is B and E. Anyone that put E is actually have a correct answer, so that's hilarious. Question number 3. NFPA Link launched around 2000 as a subscription-based platform. If an annual subscription averages about $10 a month, what is the closest total cost over 3 years without price increases? Is it A, 120, B, 240, C, 360, D, 440, or E, 600, 500? Good luck, everyone.
Well, if it's $10,
all right. So Jeremy says 10,000. That is incorrect. Looks like Daniel is going C, 360. Easy question, really easy math here.
I think I'm gonna have to agree with him.
We have 2 correct answers on that one. Good job. Only Weedman gets 3 incorrect answers so far. So let's go to question number 4. The NEC Handbook 2026 can run around 350 to 400 compared to the standard NEC. What is the primary reason for the price difference? Is it A, includes enforcement authority? Is it B, is required by the NEC? Is it C, it includes commentary, visuals, and expert explanation? D, it is printed on higher grade paper, like King James says. Or E, it contains pictures from industry experts like Ryan Jackson. Good luck, everyone. I couldn't think of any industry experts that would put pictures in the handbook, but
Well, when you look at this, basically when you go to NFPA link, it is basically the NEC handbook. That's
right.
what it is. And it's got commentary, visuals, expert explanations, all of that stuff. So I'd go with C.
All right. So you're going to copy Daniel? All right. We are correct. And we're going to question number 5. In early NEC editions, early 1900s, the cost was only a few dollars. What is the most accurate inflation adjustment computation to today? A, they were dramatically cheaper than today. B, they were roughly equivalent to $50 to $100 today. C, they were more expensive than today. D, they were free. Maybe your dad's was. And then E, they were written by more experienced electrical engineers who profited from that. So good luck, everyone.
I think it'd be like B. I think they were equivalent to $50 to $100 today based on based on cost at that time.
Really? So you agree that Daniel always gives you the right answer every time?
Well, you sort of made it there. You said it was only a few dollars, and if you paid $2-3 for it back in, or $1.50 added up today, that's between $50 to $100.
We have correct answers. We have only one away from Daniel beating you tonight.
No,
So we have to go to the tiebreaker.
He's
So
missed 2.
what I did. So what I did was I heard that you had the whole entire NFPA collection of code books from the first one all the way to the last one.
Mm-hmm.
And what I secretly did was I appraised them.
Okay.
And I appraised them at mint condition, which I'm sure they probably are. But what would be the value of I think it's 30 editions of NFPA 70 code editions from, I think it was 1890s to present. What would be the value of that collection? Like, closest guess.
I guess if I was going to look at it, I would say if they were all in mint condition.
I mean, I know they are. I know they are in mint condition. I know they're in your dad's library. But I just did it at mint condition because maybe possibly would change the guess from Daniel.
I would say if I was actually going to add it up, I would probably say about $8,500.
All right. So King James goes 8,500. Do we have a guess by Daniel? What is the value of every code book from start to finish, from the 1800s all the way till now. Every code book in mint condition. What is the value of all those code books put together? What is the value of King James? It's still not verified because we have to go back over here. Like I have to look at this over here to see if we have an actual. Weedman needs to see proof that you even have that collection in the first place. So we have to go look at proof first. But what would be the value of that collection of code books? I think that's a really good one. So you're saying 8,500?
Yeah, I would assume anything from 1800s all the way up, or late 1897. You add those, you're probably about a mint condition, 1,000 to 1,500 for that. You add up the years, so and then it starts going down. So I'd say, yeah, start adding them up. You're probably about 8,500 to 10,000.
Well, I think Daniel right now would say like 100,000, just based on his like romancer. But I don't know. We don't have an answer from Daniel right now. Like, I don't know if Daniel's still on. I don't know if he's piped in. Might be on a phone call or something.
He's already lost. He ain't answering.
Yeah, we'll see. So looks like Daniel could possibly lose. He doesn't have an answer within 3, 2, 1. And he goes B. So, all right. So King James gets the win tonight. Oh, wait, wrong button. Oh, yeah. Oh, that's the wrong button, too. All right. So King James gets the win tonight. And it is actually 3,700 is what's estimated at. And I was joking about the mint condition. I was trying to kind of boost it up, but doesn't say what condition they're in. And it basically just gives you an average, I'm sure yours are probably in mint condition, but it just gives you
They're not.
3,700, I think, is pretty good. So what would you say would be the amount to actually replace them and just buy every single one? That it would say like how much. So it's valued at 3,700. What would you say the cost is to replace them all?
I think you'd have to pay probably about 8,500.
I agree, but it says about the same, like 3,700. So it says it's worth 3,700, and you'd have to pay 3,700 to replace it. But yeah. I'm just saying what it says in the thing, and it doesn't tell you the grade, all that stuff. Because like if you have like a grade 8 code book, it's gonna go for a ton of money.
You ain't kidding.
Yeah, you're right. But that was a fun time. So Daniel goes B.
I look at it just like if you're looking at a car, say a 69 Corvette, mint condition. It's going to sell for $1.5 million. If it ain't in good shape, it ain't going nowhere near that.
Yeah, 100%. Yeah, I agree. Yeah, and that means a lot. But we'll move on to the Wall of Shame. I think you'll like this one.
Last one of the night.
Shame. 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 Shame.
All right, let's see what we got tonight.
Oh, dude.
What the hell?
Come on, man. Like, this is, to me right away, like, the first thing I thought in my head when I saw this is like, why didn't you straighten the stubs out first? Like, that's what I always do. Like, if I have stubs that are bent over like that from the underground, I take my bender handle, I I put another piece of pipe over them. I straighten them all out. I level out all those stubs coming out of the slab first. First thing I do.
That's
And what I try to do is I try to run straight as far as I can coming out of the slab, and then I try to offset, you know.
Sure.
I have an AI picture that they were like, hey, this is AI. I was like, no, it ain't. And I was like, this is AI. And the AI picture is all straight, and it has like a plate over it, and all the stubs are straight. And it's funny. Like, you could tell it's AI. This is not AI. But this came off all the same. And congrats to, you know what? I did not put the person who posted it. Oh, did?
Yeah,
I
Ryan
did.
Livingston.
Yeah. Congrats, Ryan Livingston. I stole your picture. I put it on one of my other groups, and I just messed with them and stuff. So I said, oh, yeah, my apprentice just called me and showed me this picture. How's he doing, you know? And it was really funny. And so my apprentice, he took a lot of hits this week, but I think he got way better. So all your apprentices out there, maybe your journeyman might bomb on you a little bit. It's probably because he wants you to do better and get better. Yeah. And like I say, I sent him a get well card, but he wasn't even sick. So, you know, that's what we have to do. That's what we have to do as leaders, as journeymen, and get our guys that are under us better. I need to make more me's. I don't need to make more followers. So,
all right, we're at 2 hours and 21 minutes. Dude,
longest show this year. So, appreciate y'all for joining us. It means a lot. Appreciate you, King James, putting together, dude. It means so much. It's so much fun. I'll get the audio figured out. I'll probably just set up my whole podcast thing and just get it all fired up, and we'll get it dialed in for next week. But like I say, we'll have some really cush audio when it comes next week, and you will love it. We have a home inspector that says it's okay to open up live panels and put his hands inside there and scrape off copper and stuff. So I think you'll like that. You know, it's old Paul Abernathy's little buddy. So I think you'll like that. Be like, really? Home inspector just opens up live panels and just scrapes, you know, metal off the conductor that's live. Yeah, that's not a good idea. So all you home inspectors out there that think you could do that, take a picture on live panels, not shut them off, open them up, and scrape copper up. I would not recommend that. So we'll have that for the audio probably next week, and I'll be able to deliver it a little better. And I appreciate you for all your patience, King James. I totally messed up the podcast, and I agree. I took a lot of stuff out. I should have put it back in. You know, King James is going to be like, hey, you took it out. You should put it back, you know, and that's right, man. Just put it back.
I've already got it all back in. It's ready to go.
Yeah, just if you take something out, put it back in. Put it back as you left it, you know, and that's what I should have done, and that was my fault. And I just did a little video. You saw that video was in there for a long time. And I was like, man, I should finally do this video. And then I didn't want to have the intro in there, so I took the intro out. But I took the intro out for the whole show. But you guys will have the outro because it's back in. So, as always, remember, make every day an easy day. Appreciate you, King James. Appreciate everyone watching the podcast. Don't forget to hit the likes and subscribe. Love you guys. We're out.
See y'all next week. Have a good week.